Ladies and gentlemen, I'm really pleased to be here to join the Lens World Distributed Conference and to present you our recent research work entitled Effects of Colored Ambient Light on Perceived Temperature for Energy Efficiency, a preliminary study in virtual reality. A 40% cut in greenhouse gas emissions and an improvement in energy efficiency at EU level are the two main objectives of 2030 Framework for Climate and Energy by the European Council. As stated by the Global Status Report 2017, that buildings and construction are responsible for 36% of global energy consumption and 39% of energy-related greenhouse gas emissions. According to the trends in global buildings' final energy by end use, the final energy consumption in buildings continues to grow, with all buildings and uses increasing since 2000. Space heating is the largest buildings and uses, and space cooling grew the fastest since 2000. With the spacious room for improvement, smart and energy-efficient buildings, sustainable architecture, and green design are becoming a tendency in the built environment industry. In the meanwhile, many efforts have been dedicated to the field of optimization of energy efficiency. However, human factors such as the ways occupants make use of the designed environment should be likewise addressed. The built environment can affect human comfort and well-being. On the other hand, people's choices and behaviors also influence the indoor energy use, building operations, and the performance. Therefore, more design and implementations in the human-building interaction aspect are needed. In this work, we adopted virtual reality as a research tool. Simulation technologies have already been employed as a valuable tool for design and research purposes in the field of human-environment interaction. In our work, we adopted virtual reality for investigating the effects of color ambient light on people's perception of thermal comfort for energy efficiency. People all over the world make color temperature associations. These associations are influenced by environmental and natural phenomena, human experience, situational or extrinsic causes. According to the hue-heat hypothesis, people always link red to warm temperature and blue to cold temperature. As many studies have proved that colored lights can be leveraged as an active element in creating environment atmosphere, influencing occupants' mood, visual-related thermal comfort, and cognitive performances. Also may result changes in attitude, decision-making, and behavior. In our study, the color red, blue, and yellow are chosen to illuminate the three simulated virtual rooms. An extra color white served as a neutral condition. All the four scenarios are designed with the same proportions and dimensional layout, the same number and type of furniture decorations. The experiment took around 15 minutes per person and was performed in a room with a constant temperature of 22 degrees Celsius. The participants sat at a table and for each condition were instructed to observe the ambient indoor room. When they reported being satisfied with the environment and having acquired sufficient information, a series of questions were shown up within each scenario. Thanks to the research tool, that subjects can report their attitudes and feelings inside of the virtual scenarios instead of using the traditional approaches. The evaluations mainly covered three aspects: thermal comfort, lights and ambient atmosphere, perceived context of room usage. For each evaluation, the participants were asked how much they agreed with the information on a visual analog scale. This scale was anchored to the labels "not at all" and "very much." The cursor on the line was moved through the oscilloscope controller, and the subjects could interactively select the position of the slider, which always appeared in the middle of the rating scale. 30 subjects voluntarily participated in our study. They are all college students and belong to 2 nationalities, 15 Chinese and 15 Italian. Before entering the experiment, the subjects read and signed a consent form. All of them reported normal or corrected to normal color vision, as well as normal color perception. And here is the result. In question 1 concerning the pleasant warmness, the significant main effect of color indicated that the red, white, and the yellow rooms were rated as pleasantly warmer than the blue room. This result confirms the findings of a real-world experiment. The interaction effect of color with nationality was significant and indicated that the difference between blue and white was present for Chinese. In the question 2, pleasant freshness, the main effect of color was significant. The blue and white rooms were rated as pleasantly fresher than the red and the yellow one. Similar findings are also found in package design, like blue and white always being selected for indicating the semiotic sense of freshness. In question 3, too much hotness, the significant main effect of color indicated that the red room was rated as more too much hot than the other colored rooms. The significant interaction of color with nationality revealed that this effect was present for Chinese but not for Italians. In question 4, too much cold, the main effect of color was significant. Participants rated the room with blue lights as colder than the red lights. As a matter of fact, the findings from question 3 and 4 comply with the previously discussed hue-heat hypothesis. In question 7, the light pleasantness, the significant main effect of nationality indicated that Italians gave higher ratings than Chinese. One interesting point worth mentioning is the impact of color showed a trend towards significance, which indicate that the white room received higher ratings than the blue. The reason of this trend may be that white has a general reference to pleasant and positive traits. For question 10, concerning the concentration, the main effect of nationality indicates that Italians gave higher ratings than Chinese. The main effect of color indicated that the white room was evaluated as more suitable for focusing as compared to the red rooms. The current study proved that indoor ambient light affects the human perception of indoor climate according to the color temperature association, together with its advantage for energy conservation. Besides, the effectiveness of different hues on perceived temperature, the preferred activities under different lighting conditions among 2 cultural groups are in demand of advanced investigation and explanation due to the limitation of this ongoing project. For example, the sample size, the light exposure time, level of immersiveness in virtual reality, the manipulation of other environmental factors. However, the adoption of virtual reality as a research tool for study human-environment interaction is validated, because the finding here is following in previous studies that were conducted in a real-world setting. Future development of the study could be the integration of different hues, control of photometric parameters, the collection of physiological data, and etc. It's time to bring this presentation to a close. Please feel free to contact me if you have any question. Thank you all for watching and listening.